Please welcome Chief Executive Officer of Fireworks AI, Lin Qiao.
Good morning, everyone. It's so exciting to be here. This is a beautiful venue, and I feel extremely energized with so many developers here, like talk about state of art and what we can do together to innovate into the future. I'm Lin, CEO and a co-founder of Fireworks AI. So today, I will share a little bit of our observation and experience about how to best build AI agents. There's no question 2025 is the year of agents. On Fireworks, throughout the entire year till now, we have onboarded many different flavors of agents, all the way from coding agents that is redefining what software development look like, to document agents that is doing vibe working, where you can collaborate with your coworkers in building plans, executing, and building proposals, and so on. We have also seen sales and marketing agent giving your ideal customer profile. It can automatically generate a pool of companies you can very precisely target at and send very accurate outbound information to streamline your top of funnel. We've been also working with hiring agents. Give me your job profile. They can give you a pool of candidates and even help you automatically doing the first phase of interviews. There are personalized customer agents where they can precisely encapsulate your company policy and give the best answer to your customers and hold a very high NPS. And this is not the end. There are many, many different industry verticals that has been starting to move towards building all kind of agents, all the way from insurance, healthcare, education, and so on. So probably including all of you here, you're building your flavor of agents to solve unique problems. And on Fireworks, there are many, many big companies building agents on top of us. Please raise your hand how many of you are using Cursor? That's awesome. There are many Cursor fans. How many of you are using Uber? How many of you are using Shopify? May not be that many. Shopify is a B2B company. Cursor use Fireworks, and their flagship tap, tap, tap feature, extremely fast, magical feeling of code generation, is built on top of Fireworks. And there's a massive company growing extremely fast, and they rely on Fireworks inference layer to help them reach out to biggest amount of developers in the world, including all of you. Uber is one of the biggest mobility and delivery company in the world. It transacts billions of deliveries and across different frontiers. They are on the cutting edge of developing all kinds of agents, including helping their drivers to hit the ground and run, not for several weeks to get certified and get reviewed, but in several hours. They also build personalized customer service, as well as for internal analytics. They have the automatic SQL generation, and so on. Shopify is a huge marketplace. It's kind of fourth in the world with more than 10% share. They build Shopify Sidekick to help merchants generate the best content to describe their business, and automatically generate analytics and reports. So to fully give visibility of how their business is doing without a human in the loop. So the interesting observation is those companies are building vibrant agent, having product market fit, and growing drastically, or share some common traits. One is they do not view model just as a commodity or as a utility. They actually think a model as an integral part of their product design. So interestingly, model and the product, by design, they have friction, as in the data are not fully aligned, because fundamentally they're developed by two different companies. Models are developed by Frontier Labs, where they curate data, observe certain kind of data distribution, while product is developed by startups or incumbents, where they observe different kind of this data distribution to maximize user interaction, engagement, and so on. Because of that disconnect of data distribution, without alignment, without further alignment, then you leave a lot of quality, speed, and cost optimization on the table. So that's where those companies start to figure out how to bake model as part of their product development through product model co-design. The product model co-design process is a data flying wheel process. And they figure out how to inject the data collected from the product application, make the model better, better model, power better product, more user likes to use it, and generate more data and start to create a virtuous cycle. So the end result of the model becomes their IP, and it powers their product to stand out from other competition. So these two are the two guiding principles we observe a very successful application company has been deploying and using. However, to do that, it's not a simple job. And that's where we want to deploy a lot of best practices and through our platform for any application developer to tap into this data flying wheel. We know building agent is a complicated process. It has many stages, from build, where you have a product idea and you go off and shop for the best model to support your product. The second phase of customization is when product keeps evolving and you want your model to evolve with the product through this data flying wheel. In the last stage of huge scale, when you hit your product market fit, you want to scale to millions of developers or billions of users quickly. Let's take a look at the build stage first. As this is a developer conference, you probably all observed this summer is a super exciting summer for open models. Just take a look at the LLM by itself. There's a whole slew of open models being released from the community, and they all have very different kind of innovations. Especially, many open models start to kind of doing really well in solving coding tasks, math tasks, agentic tool-use tasks, and so on. And they also innovate on how to make inference faster by building MLA, MTP, and various different kind of inference components. So if you take a look at this table, this is kind of our summary, quick summary of the model characteristics. You can see there are all different number of parameters, total number of parameters, active parameters, number of layers, KV cache size, and so on. So it covers a huge variety of space in terms of what they're good at, how they're going to run in production, how to optimize them, and so on. So curious, with a raise of hand, if you feel both excited and also exhausted going through this modeling journey. Okay, many of you. So this is there's a lot of feedback we hear similarly from the community that while it's extremely exciting and the model quality keeps increasing, this is really good for the community when they build applications and so on. It is exhausting to keep chasing every single model release. And the life cycle of a model becomes so short, every 2 to 3 weeks, it kind of stays on the leaderboard, and then boom, another model comes in and beat them. So that's where Fireworks, we come in, and we release all these models, optimize them, so you can just directly build on top of our API. To access those state-of-the-art models, you can directly go to fireworks.ai using our experiment platform. And that's where you can use more than 200 various different models from LLMs to other modalities. Zero setup needed. Just go directly use that, going through our SDK or OpenAI compatible APIs. We also have very flexible deployment for you. You can scale up or down your deployment as you want. It's designed for enterprise with privacy and security in mind. So if you're working from a company, it's very secure for you to directly access our API. Next, I would like to talk a little bit of the customized phase. Customization is basically creating data flying well. And it is not foreign to many app developers that product analytics, A/B testing is a data flying well curation process. And this is no different from that. So first you collect data from your product, describing the user intent, user interaction, user engagement, user preferences, and so on. And that data can feed into the model. I will talk a little bit about how developers do that. And continuously tune as your application product evolves. The specific technique, as Ian talked about a lot today, is built on top of reinforcement learning. You can think about reinforcement learning as how we grow up, how we have been trained during our education system from various different stages of the education, and we get a lot of reward as in, hey, we're doing well solving those kind of problems. Hey, we're not doing well solving other kind of problems. We get a lot of positive, negative reward, and therefore we grow our knowledge over time. And this is no different for doing reinforcement learning for a model. And reinforcement learning for agents has a lot of complexity. The complexity is not the algorithm by itself. I'll kind of unpack a little bit about the algorithm a little later. But the complexity relies in rising how your reinforcement learning algorithm interact with your environment. Your environment could be how you judge the result in isolation by writing code, or your environment is actually your production runs, where you just directly use the new rollouts to interact with your user and gather feedback. So here's a very wide range of complexity for you to set up those environments and accurately give feedback, give reward back to the model to learn. So it goes from when it's simple, where there's a single term agent, like you just ask a question and get back in the answer. Usually people use that to solve fixing certain kind of code. Code actually represents many things. Code can mean business workflow. It can mean SQL. It can mean design, wireframe. It can mean many, many things. So many of the kind of code problem is actually cover various different kind of tasks can be addressed through a single term reinforcement learning. And we also have a lot of classification problems can be solved here as well. Then the more complex case is multi-term. Multi-term, the complexity is you have to learn within a session of a lot of back and forth. And within the session, there are many, many contexts associated with that session. And the question is, how do you learn, during the whole entire session, which part of the reward attribute accordingly to which term? So in terms of setup, across the industry, we have seen a lot of companies start to set up MCPs to standardize the interaction and APIs. So our stack can connect with the MCP, and we have seen many vertical agents being set up that way, including deep research and various different kind of AI assistants. However, there are another setup which is more in tune to what you already have, that you have some bespoke business logic written in certain kind of program language of your preference, as well as an internal API that is not wrapped under MCP. We also have a way to connect with those different, more bespoke interaction, and then let you continue to do reinforcement learning and finish the rest of training. Happy to talk about those setup after the talk. Our intention is to make it super easy. There are many great open source tools for reinforcement learning, including RLM, VRL, Unsloth, OpenPipe. Really, really great set of tools where you can start to play with reinforcement learning locally. And that's very important important like starting point for you to kind of start to test it out and do that in a local environment and setup, and it should be easy to get going. But once you need to start to tune very large models, large MOE models, integrate with your production systems, integrate with your databases, integrate with many other things, with a lot of rounds of tuning and so on, then it becomes a very large-scale system problem, and you probably need to use a large system deployment to solve those problems. And that's where we want to make it super easy and simple for you to continue down this journey from the open frameworks. So we provide a fully managed training runs, and we give you full visibility and observability of how the trace look like from the rollouts. In one click, you can deploy and start your run. Here, let's see if we can play a video. That's where you write reward locally, where you can test locally as well. You can use your favorite IDE to develop your evals and upload your eval into the platform and start to trigger runs. And here are various different metrics you can monitor. You want to see the curve goes up and right. And there are many different scores you can look into. We also provide a debugging panel where for each rollout you can hand test the prompt and see the results. Cool. Just want to show very, very exciting and promising results. We have seen using reinforcement learning, there are many companies, they are able to beat off-the-shelf models by using their own data. On the left-hand side, we have an agentic tool use case, where we started in the middle is the open model. That is a very small open model. The quality, the y-axis is the quality was much worse, and after tuned, it becomes 4% better for the agentic tool use case. The second case is a code edit. Keep in mind, code means many things. It means business workflow, SQL, design, and so on and so forth. We start in the middle. That is also an open model, small open model. It was 13 times worse in terms of quality, and after tuned, it becomes 15% better accuracy. Now I would like to talk about how to scale to when you want to, after you hit the product market fit. During the scale phase, you will start to worry about many things. Which hardware should be using, which cloud you would like to pick and choose, which region to deploy, and how to debug a whole slew of issues and errors across a rich infrastructure stack. So we take care of all of that for you. Today, we're running across 10 cloud providers over more than 18 different regions. Our disaggregate engine for both reinforcement learning and inference give you the best performance. It's highly reliable, and we do global scheduling to reach the reliability and the efficiency. We also have enterprise-grade privacy and compliance baked in. So to dive a little bit deeper, the secret sauce between our disaggregate engine is called a 3D optimizer. At a high level, it optimizes for these 3 dimensions: the model quality, speed, and cost. The bad news is actually it's not easy to do, because just those are kind of we just listed a set of elements that we need to optimize for. For example, just for speculative decoding, the speculator, we have more than 5 different ways of flavors of speculators. We have 8 different ways to quantize a model. We are running on top of many different hardware SKUs. There are many different ways to shard and partition the model and distribute them out. And the distribution can run on single node or many, many nodes. And we have also many different kernel selections based on workload pattern and so on. And all these can compound and stack onto each other and lead to more than 100,000 different options. So this becomes a search problem. And we want to pick one option out of these 100,000 options that is most optimized for your particular application. That's kind of a representation of our design philosophy is we don't consider inference, we don't consider model as one size fits all. We consider inference and the model combination as one size fits one into your specific application. So here's a show of some numbers. Today, Fireworks is running more than 10 trillion tokens a day. And we process more than 180,000 requests per day. Just put in perspective, this is in the ballpark of Google search traffic volume. I just went through a journey for building AI agents from build phase to customization to scale on top of Fireworks. Before I end this talk, I want to call out that we have been working closely with MD to optimize the state-of-the-art open models and build on top of the best MD hardware. For example, last year, we launched Fire Attention v3 that is purpose-built for MD hardware. And at that time, we have achieved 2x higher performance compared with other options. And I'm super excited this year. We continue this collaboration to build on top of the best of the breed of the AMD hardware. And I'm very excited to see what we're going to build together. Thanks, everyone.